So today we are going to be talking about arithmetic versus geometric sequences, and today is November 17th. We're going to start with reviewing about arithmetic sequences. So arithmetic sequences, remember, they increase or decrease by the same amount between terms. The amount we increase or decrease by is called the common difference. The graph is linear, and the recursive formula has addition or subtraction with a sub n minus 1. So the formulas, and this is the important part, the formulas, we have recursive, so there are two ways you can do the recursive formula. The way we learned it at the beginning of the year, we said a sub n or equals curly bracket a sub, or well, yeah, we said, sorry, a sub 1 when n equals 1, a sub n minus 1 plus the common difference when n is greater than 1. Another way you can do it, and you'll probably see this in some of your answer keys because this is how we've done it in the past, is u sub 0 equals, and that ends up being the starting number, and then u sub n equals u sub n minus 1 plus d. The explicit formula is a sub n equals a sub 1 plus d times n minus 1. You could replace the a's with u's, so if you wanted u sub n plus u sub 1 plus d times n minus 1, that would work. Another way to write it would be a sub n equals a sub 0 plus d times n. So if we use the 0 term instead of the first term, we would just be adding d times n. Doesn't matter which one you use. So either way, the formulas are one of the most important parts, the thing that you need to know for your test or quiz. And again, I don't care if you use a sub n or u sub n, both are acceptable. So pick one, love one, and do it. So that's arithmetic. Geometric is different. Geometric sequences multiply or divide by the same amount between terms. So arithmetic adds and subtracts. Geometric, we multiply or divide. We have a common ratio. That's going to be important. And I mean, I should say we're going to multiply. Okay. Dividing you can think of as multiplying by a fraction. So the common ratio is the number you multiply by to get the next term in the sequence. So common ratio is going to be the number you multiply by, and again, I'm going to emphasize multiply. I don't want division symbols. We're always going to multiply to get the next term in the sequence. The graph looks exponential it's not technically, I mean it is and it isn't, but we'll get to that on Monday. Basically, it's curved. And then the recursive formula has multiplication with a sub n minus 1. So let's go down to the formulas. Again, the most important part. So just to be warned, the answer keys that are all made use u sub 0 and u sub n. If you'd like to be consistent with what we've done in arithmetic sequences earlier this year, we can use a sub n. So recursive is going to be a sub n equals a sub 0 when n equals 0. So we start with 0 with geometric. If you'd like to, you can also start with 0 with arithmetic. And then a sub n minus 1 times r, that's going to be our common ratio, when n is greater than or equal to 1. So that is the recursive formula. If you wanted to use u's, so I'll say or, you could do u sub 0 equals, that's the starting number, u sub n equals u sub n minus 1 times r when n is greater than or equal to 1. So that's recursive. Explicit will be a sub n equals a sub 0 times r to the nth power. So times r to the nth power. Or you could do a sub n equals a sub 1 times r to the n minus 1. Okay? These formulas are the most important part. You'll be using them in your homework and in the examples that we are about to do. Some important pieces. So we've done arithmetic sequences. To find the common difference, you subtract your terms. To determine the common ratio, we are going to do the second term divided by the first term. And that will give you r. And you can do that like third term divided by second, fourth term divided by third, depending on how many terms you have. You'll have growth, which will occur when the values are increasing. Which means the number you're multiplying by your common ratio is going to have to be bigger than 1. Can't be 0. And then decay, your values are decreasing, so r is going to be, r is going to be in between 0 and 1. So it can't be 0, it's not going to be negative. It's going to be between 0 and 1, basically meaning a fraction. So 1/2, 1/4, 1/3, etc. Alright, so let's do an example. Example 1, a car costs $14,000 and depreciates by 12% each year. So, part A, the first thing I want us to do is determine the car's value for the first 3 years. So what we need to do is determine r. So to find r, the common ratio, I'll say CR just for common ratio. We know that it's depreciating, so it's going down by 12% each year. If we go back to geometric, if it's decaying, okay, it's got to be less than 1. So what we're going to do is we are going to subtract from 1 12%. But 12% is a percent, so we need to change it to a decimal. So 12% is 12 over 100, so we rewrite this as 0.12. So then the common ratio is going to be 0.88. So now what we can do, we could make a table to figure this out. So we have years, we have the value, we know that the car costs $14,000, so right when we get it, the value is, we'll say 14,000. And then what is it going to be after 1 year? What is it going to be after 2 years? What will it be after 3 years? So to figure that out, we are just going to multiply. So 14,000 times 0.88, and that gives us 12,320. So after 2 years, we now take this value and multiply it by 0.88, and we should get $10,841.60. After 3 years, so we take this number, 10,841.6, and multiply it by 0.88, and you should get 9,540. We'll round to the nearest hundredth, 61. Okay. Alright, so there's going to be more parts. There should be a second video.